This video moves along fairly quickly. Trying to cram 3 hours worth of work in 10 minutes of video is a bit challenging. One thing you'll want to do when you do the lower control arms on two-wheel drive vehicles is take the brakes off and lighten the load of the spindle. I figured that the spindle weighs 65 pounds and with the brakes installed you're probably over 100 pounds. So hang your caliper up with wire, as you've probably seen by other videos. I used a milk crate to set the spindle on because I didn't want to take the wheel hub off, and it has the anti-lock sensor on it. So I used the milk crate to set the spindle on with the wheel hub still attached. Sway bar comes loose. 5-pound BFH works well. On the disassemble, I didn't speed the camera up at all. On the assemble, I went to 8x speed so that I could cover both sides. This will be a good time to change the spring insulator if it's worn out, or the springs themselves for that matter. The new control arms did not come with the bump stop, so I had to pry the old one off of the OEM control arm. The reason I had to change these control arms is this was a failed attempt at replacing the lower control arm bushings into the OEM units. And I've tried this before and it never works out well, but I tried it again and here I am doing it a second time. But changing the bushings out on the control arms stretches the material, the eyelets, out, and they don't retain properly. So it's just better on these stamped steel pieces to change the whole control arm. The problem is there's such a contrast in quality of parts these days, from OEM, from the dealer at $500 a piece, to the Asian models, which is all you can get in aftermarket these days. Moog is a quality aftermarket replacement option, but unfortunately their K series was not available, which is the quality side of Moog, with the problem solver gusher style ball joints, but they just don't make them for this truck. So I couldn't even get the R series in Moog. They would have been a week and a half, 2 weeks before I would have seen those. So I chose these MAS units. They worked alright, but oddly the left control arm had a serviceable style greasable ball joint with a castellated nut, cotter pin feature for retention, and the right side had a non-greasable or non-serviceable style ball joint with an elastic lock nut. Kind of odd. Even had time for a break. One of the most important tools you'll see in this picture is that purple pad for kneeling down on. Second most important tool in this picture is that 5-pound BFH. I'm going to rephrase that. Most important tool here is my hands. And I came out of this job with no bruises or cuts, thanks to pry bars and dead blow hammers and patience. I left the lower control arms a little bit loose. It makes putting the spring in easier as you roll the control arm into position. Once the weight's on the springs, then you can torque them down, and this truck gets 200 foot-pounds of torque on those through bolts. Apologize for the darkness on this side of the vehicle. I just couldn't get the snap-on light to position enough light for both the lower and the upper part of the video, and I figured we had a good footage on the right side, so I'm using a GoPro Hero 4 on 720 widescreen mode. At the end of the video, I mount the GoPro on the front bumper and take it for a drive. There's a difference in the size of the castellated nuts from the OEM versus the aftermarket. Just couldn't justify $1,000 in control arms for the OE units. If they would make it priced a little bit lower, I probably would have went for it, but this truck's not worth $1,000 as it is with 300,000 miles on it. Torque everything to spec and then go to the next hole on your cotter pin to line it up. Just nuts and bolts. I used Lucas high pressure grease on all the parts. It's a green colored Lucas tubes you see in the auto parts store. Good stuff. Excellent stuff. I even use it on my boat. I think it's marine grade. As promised, the end of the video. Thanks for watching.